So the first thing I want to do is find an anchor point, something that tells me exactly where the graph begins and ends. And in this case, I think cosine is the best one to use. And the reason is because if I look at the graph, so let me go to draw here. Oh, there we go. So if I go to the graph, I see the highest point occurs right at a grid point right here. And let me change colors here. So right here is the highest point of the graph. And I also see another high point right here. This is the classic case of cosine. So cosine starts high, goes to the bottom, comes back up to where it started. So I am instantly going to say, okay, even though I could start with sine, sine would start like right here or right here at the midline, but I think cosine is the best choice. So I'm going to start assuming this is cosine, and I'm going to start identifying all the features. So I'm going to look at the midline. The high is here, and that looks like 3. Okay, so the high is at 3. The low is here, which looks like 1. The difference between 3 and 1, or oops, negative 1. The difference between 3 and negative 1, well, 3 minus negative 1 would be 4 units total. The amplitude, though, is always half of that. So amplitude will be 4 divided by 2, or just 2, which means the midline is going to be 2 units from the top or 2 units from the bottom. So 1, 2, or 1, 2. So the midline is right here. So there is my midline. That tells me the vertical shift. So the vertical shift is up 1. Okay. Okay, and notice I actually say up. I'm not going to just say 1 or plus 1. I'm going to say 1 or an up arrow and 1 to make sure that I don't confuse that. So now I have that. I have the amplitude. I have the vertical shift. I need to know if there's a phase shift, and there is, because cosine would normally start along the axis here at the top. So I need to know what's the distance from here to here. And if I go and look, it's pi over 3 here, and there are 4 marks. So I know the phase shift will be pi over 3 divided by 4, because that's 1/4 of that. So pi over 3 divided by 4, which is the same as pi over 3 times 1/4, which is pi over 12. So then the phase shift is pi over 12. That's the phase shift right there. Okay. And now I need to know the period. So to find the period, I'm going to look at from peak to peak. It doesn't matter where you do it. So you could actually start from here and go to here. That would be 1 period. It really doesn't matter which 2 points you use as long as they are corresponding points. Okay. And so from here to here, well, that is 4 pi over 3 plus pi over 12. And the thing is, though, is I don't want to do that calculation. So I'm just going to slide this period. If I look carefully, I'm 1 unit over here. I'm 1 unit over here. That means I could have chose this point and this point as well. And that would have put me right on the grid. And now it's easier to calculate that out because it's 4 pi over 3 minus 2 pi over 3, which is 2 pi over 3. So then that is the period. So my period is 2 pi over 3. So I'm almost to the point of writing an equation. I have one more step to do though, because I can't write an equation directly from this information that I have, because one of the numbers in the equation is not the period. It is a period adjustment. And so if I look at this, what has happened to the period? Well, the usual period of cosine is 2 pi. That means that we've divided our period by 3. And if you remember back, horizontal always lies to you. So if you're dividing by 3, your equation is going to look like it's multiplying by 3 because horizontal always lies to you. So I'm going to build my equation now. So y equals, and if I look at my amplitude, amplitude is 2. It's not flipped upside down because I'm starting at the top. So just positive 2. I'm using cosine. I know that my period has been divided by 3, which I know horizontal lies, so I'm going to multiply by 3. I need an input variable. My phase shift is pi over 12, which horizontal lies, so since I've moved to the right pi over 12, I need to subtract pi over 12. And then vertical tells the truth, so vertical shift is 1 up, so I'm going to add 1 at the end, and that right there is an equation for that graph. Now it turns out that that's not the only equation you could write. You could write one for sine. You could write other ones for cosine, because you could have said, oh, I actually want to treat this as a flipped cosine and start here. Then your phase shift would have been back. You would have been flipped upside down. But the only things that would have changed would have been the phase shift and whether it's flipped upside down or not. The rest of the numbers would not change. The amplitude would still be the same. The vertical shift would still be the same. These two numbers right here are dependent on each other. So if you change, I'm sorry, not those two. This sign, so this number right here and the sign that goes in front of here are dependent on each other. Period stays the same, vertical shift stays the same, amplitude stays the same, but the sign in front of the two will be dependent on what your phase shift is.